Catus Maximus here. We're going to do a teardown of this Dremel SawMax. This is the SM20. I believe they have a SM40 or some model number like that. This is the original one with a 6 amp motor, and then they have the Ultra Saw, which has a 7.5 amp motor. Anyway, this is just going to be a quick little teardown, a little description. This is a little worm drive saw that's a left-hand blade, so kind of like a miniature skill saw. It's supposed to be pretty well made. It seems like it's pretty heavy. Seems like a decent tool, but for some reason this one got burned up. So who knows if it was a factory defect or somebody really ran it very hard. It only takes 3-inch blades, so it's actually pretty hard to overload these, and that's one of the things people like about it, is it's just compact, and it just has, since it uses such small diameter blades, it's pretty hard to overload. So either it was a defect or somebody was really just like, I'm not sure, standing on it. It has a lot of wood debris, so it could do full depth of cut pretty much as hard as you can push it. So it seems surprising, but maybe somebody's using it and was grabbing it like this and blocking off the vents and overheated. Anyway, it's pretty obvious that it has a severe issue with the motor. It just buzzes. So there's obviously that sounds like there is some shorted windings in the armature, and so it's just hitting those points and just buzzing. Anyway, let me unplug it here. It's not worth fixing. It's $60 for a field and motor, and you can get one that's refurbished from like CPO outlets for $60, free shipping. And this refurbished one is advertised to look like new, comes with new packaging and new accessories. So there'd be absolutely no reason to replace the motor. And like cars or so many other things, the cost of a tool's parts, particularly primary ones like a motor, the armature and field, and this is something where you could probably get away with just replacing the armature, but with this kind of electrical issue, I wouldn't really trust the field, and that's $60, so why not just get a refurbished one? So I'm just going to tear this one down. This screw is actually a right-hand loose. Since it's a left-hand blade, it uses a counter-threaded screw, so I'll end up keeping like some of the accessories if I ever decide to get one of these, particularly with things that are easy to get lost, such as these little washers and the bolt, and maybe some other parts like the trigger or something. Otherwise, we'll just do a teardown. What I should do is measure that. And annoyingly, there's a standard with like die grinders and even like old Porter cable trim saws. A lot of them, the spindles are 3/8, but for some reason Dremel decided to go ahead and use a 7/16 diameter, which is much more difficult to find. One of the annoying things about Dremel, and it means that you can't just use standard 3/8 arbor blades. You have to find special 7/16 ones. It's a little bit bigger than 11 millimeters, so it is a fractional diameter there, surprisingly enough. That's about 11.1 millimeters is 7/16. So I find that a little bit curious, but I haven't done a lot of research. Maybe 7/16 tools or accessories are a little bit easier to find. Anyway, I'm going to go ahead and knock this thing apart here. We'll use this little Makita. I'm going to end up getting a battery for this because it works pretty well, and it doesn't have any electronics to really burn out. This is just a switch. Really like this thing, but it just didn't sell well because it was just, really, it was honestly pretty weak 15 foot-pound impact driver, and especially for the cost. But I thought it's great for disassembly work such as this. Super fast for getting these screws out, and it's not as big and heavy and bulky as other impact drivers. And people can get a look inside. So it appears I do have to pull off this case here. Those are little T15 screws. The screws seem pretty nice, pretty big heads on them, kind of like socket head cap screws, but with Torx. And I didn't loosen up this thing. This can be adjusted, so if the shoe isn't isn't tightening and loosening, this has multiple positions for you to be able to work on that. So we'll just, I bet this unscrews all the way out, and it sure does. Wonder what holds that in there. Well, we'll see in a minute here. Let's see if we can't get... Well, that will come apart. Is it the... Oh, I see. We pull off the back side here. That's not boding well. Oh, it all just falls apart. Interesting. So, as I mentioned before, pretty much all power tools, or all power tools and chargers, for at least 20 years have had integrated asset tracking tags. They're stolen so much. But what we can see about this one is it looks a bit melted. So this thing may have just been run really hard. Yeah, that definitely is melted. So this may have been run just really, really hard and overheated, and that's why it failed. Anyway, interesting that you can just pull out that fastener, those 4 screws, and then this whole assembly just comes apart. This is our spring. I assumed it was hiding up here. That looks exactly like where it was hiding. Maybe something like this. Anyway, that's the return spring. I don't need to worry about figuring out how to get that back in place. It is a nice casting for the metal gearbox. We can see ball bearing there. I mean, the spindle in this is tight. This is not a gear problem, by the way. I mean, this spindle here, this turns totally freely. The gears feel smooth, so it's definitely a burned up motor. Here's our lock button. We have a rubber seal ball bearing there. Spewing all of its grease out, which is other evidence that it was run pretty hard. This is definitely a greasy tool. Let's get the other part of the clamshell. Oh, I see. These screws are screwed in this way, so this has a particular order. You do have to remove that cover. You have to remove these screws, and then you can split the clamshell. It's kind of interesting because this is one piece pad here. I wonder how this is kind of held together. Anyway, we should get these. Oh, I need something longer here. And I bet these are T20s. Yeah, those are a larger screw. I wonder if this will give me enough length. Oh, it looks like it. Four screws here. It's a nice tool, just, you know, I guess it kind of has limited use for a small saw like this. And if you already have a small saw, then it's hard to, of course, to justify something like this. But if you're just doing simple cuts, more, you know, I guess cabinet work or some stuff like that, then this could definitely be handy. This doesn't just want to pop out, so it looks like we do have to split the clamshell after pulling out those cross screws. It also explains why there isn't screws on the front part, because it's relying on those. Now, oh, interestingly, no, I was incorrect. This piece is a single piece of mold, and it's just this back cover that is, there's some kind of plastic thing here. Oh, I see. This is just something to help protect against the side that has the brushes. I guess maybe it's like a, you know, it's like probably a high temperature material to prevent the brushes from softening and melting into the plastic because it's so compact. Anyway, we'll get the brushes out of here. Whoop, let me get this. Kind of odd. The strain relief is actually T20s. Pretty easy to replace the cord. That's a standard design. The strain relief is, just going to get a little more zoom in here. The strain relief is independent from the power cord, so if it wears out, it's pretty easy to replace. You can just pop off this back portion and then just pop this out. It does have a lock-on trigger, right? Trigger capability right there. Kind of keep the parts that I do want to keep separated from the ones that I don't want to keep. Get that loose. Then we ought to be able to slide this other cover off. There's our other little insulator. Actually, I should probably keep those. Those might be handy in some kind of other tool. just a push button switch, kind of like an angle grinder uses. It is nice to see that it has a rubber boot to keep it sealed. And we have Phillips screws actually holding on the wires. You know, some of these decisions always seem strange because you're going to be using Torx to get into the tool, then all of a sudden you need a Phillips to do the wires. Why not just have these be Torx as well? Pop that out. And I've learned that doing this, putting these little crimp ferrules on the ends of wires, helps prevent them from getting loose over time. So it's nice to see that they've done that. This power cord and strain release actually still just fine, so I'll probably keep this for another tool. I actually have another tool in mind to use this with, or for, I should say. Now I want to remove the brushes. We can see this thing was like brand new. The brushes have hardly have any wear in them whatsoever. I see we have our wires in their magical little pathway here. Another one in a little magical pathway. I probably should unplug that stuff, but I kind of want to get... Oh, I see. It's spade terminals that are holding it together. Let me get some pliers. So, as far as, since I kind of like the idea of this, and I, you know, someday may end up buying one, just seeing that it's only $60 for a refurbished unit, I will keep power tool parts around for a while, and then I'll periodically sort and toss them. But when I tear apart something like this, you kind of really figure a lot of things are pretty reliable, like the gearbox and stuff. If you use one of these to the point where you blow out the gearbox, you should just buy a whole new one anyway. But some things like this little lever here, the shoe, these are the type of things that if you drop it, it will break. Those are the things that break, and so those are the kind of handy items that you might keep as spare parts. So let's get this trigger unplugged. And something like this will be relatively standardized. There'll probably be a variety of grinders and some other tools that a switch like this may actually work with. And let me try to zoom in some more here so we can figure out what this switch is rated for. It appears to be 5 amps at 250 volts, 10 amps at 125 volts. For a 6 amp tool, that's not too bad. That's reasonably overrated. Really strong spring in this. I don't know what brand this is. Anyway, seems like a decent unit. That's something I, of course, will end up saving and keeping. Should probably keep these little screws in here too. Well, I'll deal with that in a minute. Anyway, let's unplug the rest of these. We actually have the brushes have integrated copper wires embedded into the brush itself, as well as being in a conductive brass guide, so that ensures that you have just plenty of extra. I want to try to get this out without damaging that wire, but it ensures low resistance. And ooh, that's a little bit loose. It's kind of difficult sometimes to pull these off without putting too much force on them. This is always a challenge here, especially with these brushes, because it's easy just to grab and yank them and actually break that wire off. Once we've done that, we'll just do the little thing where you take the clock spring and you kind of just lift it up and pop out the brush. Many times you can just set the clock spring right off to the side. In this case, we won't be saving this, so I'll just let them back down. But the things like these brushes have relatively standardized sizing. And so these, we can actually see the wires are kind of in a special place. They're the same brush. So you always keep brushes like that in spare parts because it's inevitable there'll be some kind of tool that can use them. And it looks like we have little T10 screws there that hold on the brush guides. I'm trying to keep this in frame the best I can. Kind of hard sometimes to do a teardown when you're behind a camera. Camera's in your way. And then that should lift it out. And there's our little brush guide assembly. That's quite the assembly here with 3 different terminals. So this will probably be used in a variety of Dremel tools. And of course the same thing on this side. Shame this thing is this unit failed, because it actually seems to be pretty well made. There's actually quite a bit of mass in those as well. Anyway, now that we've got this mostly apart, I wonder how we get that out. I guess we'll have to figure that out in a minute. Now we have to basically try to pry or yank the gearbox out of there. I assume, since this is a saw and a pretty robust power tool, that this is just going to be in here pretty stout. Yeah, it's just really tight fit. So we just pry it. You always want to remove the brushes first, otherwise it can get stuck. So let's take a look here. The only thing that seemed, yes. And so what has happened here, actually I'm not entirely sure I know specifically what has happened on this. I'm trying to take a closer look. I once took apart a grinder where the wires actually just flew out of the armature. But in this case, we see damage right there. So that's either one of two things. Either this was overheated and the wires actually expanded and started to push out and kind of welded themselves together. Or this may have been just a defective motor. One of the things I'm surprised about is if we look at all these undercuts, this motor, look at them, this motor was severely off balance. Nothing on that side, but they had to remove just a ton of material. And that may be indications that it had issues during, it was just a defect in the motor's winding. And unfortunately, that defect resulted in it failing. But that probably, you know, they probably should have something in the quality control process where, you know, when you've removed this much material, that the armature probably should have been tossed. And we have all this warbling. These are just, you know, I don't know what the material is, but it's a hard fibrous material that they shove in here after winding it to keep the windings down tight. And when you see like little bulges and that type of stuff, really bad news. So I'm going to write this up as just a defective armature that finally ended up collapsing and basically shorting out. And then we have just a little fan guide, and then we have the field, and the field is probably okay in this unit. As far as getting it out, usually you have to hammer it on something pretty hard. You always make sure this one doesn't have any screws, it's just a friction fit in the body. I got the field out, and this is actually another unique one. I've never seen a two-piece field like this, and I have no idea why on earth they would do a two-piece field. Yeah, you can see where that winding that expanded had actually been physically rubbing on the inside here. This may be due to ease of manufacturing, because on closed fields you need a special machine that has like a little needle that goes in, wraps it around like this. And if you decide to cheapify and do a split field, then it takes a cheaper, then you can just do a winding and just have a machine that just sets it in there. But I've never really seen that before, a split field. Maybe I have, but that's definitely pretty unique. We can see some things that I don't like. We can see the nice copper color here. We get down here and then you can see some blackening right in there. So this would be a situation where you would, and some more blackening there, where you would have to replace the field and armature. And that's 60 bucks. It's surprising that you can get a like new refurbished unit for the same price as just an armature and a field. So now this is the complicated part. I won't bet that this is going to be press fit into here, and like more or less a kind of a permanent type of assembly. Guess we'll pull that out. I'm going to spend a minute trying to figure out if I can't take that apart. So there was like a little E-clip on the back of the spindle here, but it's still like press fit in there. That may have been just to ensure that that bearing doesn't shift around. This thing runs super smooth. I mean, it is built like a little skill saw, except for they just grease the gearbox. It also means that one of the issues, the way this is designed, is one, we can see when it gets hot, it pushes all the grease out through the bearings, through the little hole for the lock, and it's not easy to put it back in there. The only way I see that you could add grease back into this is actually through that pinhole, where you need to disassemble this. Fortunately, it's not too bad because you just pull off those two front halves, remove the lock button, and then they make grease injection needles for grease guns. You know, all sorts of places, Napa and stuff sell them. And you need to put that down in there and actually periodically put a couple of pumps. Maybe, actually, this is so small, probably just one pump of grease in there. So you can't clean it out, but at least you can add grease. So I'm going to try to knock this thing out first. And then as far as getting the armature out, that's going to be difficult. There's a place to support it on these tabs, but you need something pretty long and deep to be able to, with a lot of clearance, to pass the motor. Let me work on that. Alright, so if the ending of this video seems a little disjointed, it's because I had a big adventure trying to figure out how to get this gearbox disassembled in the proper way. And Dremel only sells this gearbox as an assembly. They do sell the armature separately, but this can be disassembled and you can replace the bearings. But it's a special process. What you have to do is, this is actually threaded, so this spindle, which is crossways through here, there's a very difficult to remove snap ring and an E-clip on the bearing. With a difficult to remove snap ring here, there's another one holding this bearing in here. But this actually threads into the back of the worm gear, and it goes through the housing. So you have to, and it's difficult to hold onto the pliers because this wants to twist at the same time you're trying to turn this. So you just put this in a vise, hold on to those two flats. This is small threads. They weren't particularly tight. Actually, just grabbing it with two hands or a rag and like just some vice grips, not too tight. And this unthreads counterclockwise. This is just normal. You unscrew this. That removes the armature. Then what we have is we have a bearing here. That's the only place where there isn't a snap ring. We can see that they did attempt to put like an O-ring in, a rubber, big thick rubber, kind of like gasket and O-ring there. Once you've done that, then you can drive this worm gear out through the front. Since this worm gear sits into this spur gear, you have to remove the worm gear first, otherwise the bearings get stuck on the worm gear. So pull the armature, knock this out through the front of the gearbox, then you can get this snap ring out of here and drive this out this way. Once you remove this snap ring, you just use a punch to knock that bearing out, and so you could actually replace the bearings. These are pretty thick, heavy-duty, hardened steel worm gears. They're not oil lubricated. They just use grease. So you'll periodically want to put a dab of grease through the lock pinhole. That's the only way to add grease to this. This doesn't seem too bad but there is some wear on this gear. This tool was burned up, so I suspect this is part of the issue. What is a disappointment about the grease is that really it means that it's more of an occasional use tool. Because if you, let's say you like it a lot and you're installing flooring, or you do a lot of, like, you know, plywood work, that type of stuff, and you may just want this little saw, using this for long periods of time, since there is no oil bath, the grease will kind of fling off, and then this is just steel on steel. And unlike spur gears, a worm gear, of course, by its nature, is constantly sliding and grinding. That's why things like skill saws and other worm drive larger saws have oil-filled gearboxes, because even versus helical gears, this is a screw. It is constantly sliding against these teeth. You get a huge reduction ratio in a compact gearbox, but over long periods of use, these are just going to get hot. There's not going to be any oil in there because they're spinning and flinging it off, and it's going to wear out the gear teeth. So this is a bit of a disappointment. They should have had a way just to have a little bit of oil, actual liquid oil in there. It would have done wonders. But this, I can tell you that there's a reason why skill saws and other worm drive saws, even little Porter cable worm drive, 4.5-inch trim saws, have an oil-filled gearbox, is because it needs the liquid oil to constantly be getting into these gear teeth to prevent them from grinding away due to the nature of a worm drive. So even though this is very heavy duty, this hole here is where that lock pin goes through. Anyway, other than that, it's pretty decent engineering. A lot of complication, and I just wanted to be able to kind of finish out this teardown video with actually successfully tearing down the gearbox and knowing how to do it properly. Unthreading the motor by holding the spindle, knocking out the worm gear through the front of the gearbox, and then removing the snap ring, and then knocking out the blade arbor through the other side of the gearbox. And then of course the last thing would be to remove this snap ring and knock that bearing out, and you could actually replace the bearings. But if this ever got to a point of needing to replace the bearings, I suspect the gears would be just about stripped out anyway. Anyway, I really appreciate everybody who's been watching and subscribing, and if you haven't subscribed, please do. Until next time, Catus Maximus out.